Well, on the bench today, we have a pair of bullet fans. Da-da, 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 da-da. They need a lot of work. Well, we're going to try to get them going, and then customer's going to paint them. He's got the blades and the guards and all that, but we're going to see what we can do to get one, or if hopefully both of these going, but we'll see what we can do. So let me set up and we will continue. Okay. This one looks like to be in a better condition than both. So we'll start with him. Oh, now that ain't cool looking. Wait till you see the inside of this. It's from Star Wars. What were those walking things? Shot? Anyway, that's what we got. Oh boy. Okay, let's see. Do we have a head wire? We got a switch. No, we have no wires at all. Ah, here they are. Alrighty. Let's see. Oh, we got broken wires. That's not good. That's not good. That's not good. We have a broken wire there. Now, what is the deal with that? Maybe one's a starter wire. Ah, yeah. This one's wrapped around here. That ain't connected. That's just wrapped around there. So what in the world is that? Oh, that is frozen up. These may be beyond hope. Somebody did something here. See that crack there? Not closed all the way. Oh, wow. Man, that was tight. Let me get this one loose. Yeah. Stand it back up. I don't think the force was with this one. I think one of the Jedi's hit this sucker pretty hard. It has the condition of petrified grease. Turn the glue. Set that there. Get a bag. Free gift for the landfill there. Okay, now how can we get this to go? That's turning. I don't know if it's the gear that's locked up or the wow, I don't know what's going on here. Give it a little love tap. Ooh. Oh boy. Okay. We gotta disassemble it completely. Let's see if I can get that gear out of there. Take the pressure off this. Like this. I don't even know. That's so frozen in there. See, that's the front of the motor. Oh, let me try. Let me try. Okay. That won't fit in there. There we go. It's got a plastic in. Oh, it is plastic. The whole gear is plastic. Okay. Wow. That is as tight as can be. That ain't gonna run. Get some oil in it. Let's go somewhere down here. Oh, that's good for. Ah, there it is. New container of 3-in-1. They work. They just come out like that. Yeah. Okay. Get it up right. Let me see if we can get some in this side. Wow, that's tight. Dang. Okay, it's turning, but boy, it's tight. If that spins, I'll be amazed. Okay, it's getting a little looser. And I think we got it going a little. Yeah, it's falling on its own weight. That's a good sign. Okay, let's see if perhaps, I don't even know what these fans are, that's the problem. We know these two go with this one, so I'm going to set them on that side. Let's see if perhaps we can get a better indication from this one as to what those head wires are supposed to look like. Oh boy, this one's shot. Look at that. Totally shorted out there. I can separate them, but I don't think that's going to work. And I don't see the head wires in this one, which is really weird. Let's pull this up here and take a comparison view. Just rearrange some things so we can see. All right, what do we got going on here? And can see that wire's busted. There was a cut right through there. I can't do nothing about that armature. I can try to separate them and see, but it looks like more than one is cut. This one, I'm not seeing any cuts, other than I got some kind of freaky thing going here. Okay, this is obviously the original wire here. I don't get this twisting around bit there, and because it's shellacked, so I know that can't be factory. That wouldn't even be making continuity. That's the next test. I can't find nothing from that one yet. Let's get our meter over here and see what we can find out. Can you see that? I think you can. Maybe if I pop it up a little more. Yeah. Probably not. Not going to happen. Not the best I can get it. All right. Hold on. Sometimes something with grip does better. We'll assume that that's going to work. Yeah, you can see that. Okay. Get some slack. Yeah. That's dead. No, I don't know. I don't think I'm going to get anything across this. Neither working. On continuity. Hold on. Get a better connection here. This project may be over before it begins. No, I'm not getting nothing. And that other one was totally broken off, just wedged in there. Not enough to hold. You know, he's pretty strong, but that one was totally discombobulated. I don't know. I don't know about this one. And I think these things are going to be self-cleaned. I don't think they're going to be repairable. No one's going to want to put that much money. Okay, we got continuity on that one. So that's what it is. This is one coil. And this is another coil, individual. I'm going to have to find the wire, which is not going to be easy. Maybe I can dig it out. I don't know. And I don't know. With a little bit of luck, it's going to be. Put my eyes on. I'm going to need my eyes for this one. I'll move this back. Right. Let's see if we can find the other end of this wire. That's twisted. That's where that came from. Okay, one of them is on the outside, and the other one is the inside wire. And this looks like it's the outside. And the inside wire. And it's broken off in here. Oh, look at that. That's just ridiculous. That one I can get to now. It's the other one that's the problem. I think I see it. Right? No, no, no. I'm going to have to cut this free. See the inside of these. So, it's coming across here. It's a dog drive out of it and turn a stone. Here also. stator might need to be rewound. I know that one needs to be rewound. It's damaged beyond belief. This one, if I can find the wires, I might be able to run it across. Apparently one of these connects to this side, and the other one is the head wire, and then there's a head wire here as well. And you see how they're bent? They're bent out of shape here and here. I have no idea if this thing is shorted inside. I don't think it is. Getting by this stuff is not easy. This stuff is, and you got to be careful. You scrape the coil, and then you get another problem. As long as they don't short out, it don't matter. But get that out. Try to squeeze it up. Try to squeeze it around, getting a little bit less sharpiness. I don't know how to find that crappy thing. Where are you? Where are you? You should be in here. This is one end of it here. And the other end is in here. So it looks like the inside wrapping coil connects to the inside here, and the outside are the two of the AC line. And this was a one-speed fan. It definitely oscillates, but it's a one-speed fan. Think of it at this point. And that one, see how it's got play? That's much better. This one here, it looks like it might have got cut on this side here, right near this shim. Let me see if I can get that stator out of there. I'll get the stator out, I don't know. It's worth a shot. Heavy duty, 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 duty. Oh, instead of just bolts on the front. Oh, that's interesting. That doesn't even go in the case. Okay. Wow. Oh my. No wonder I didn't want to turn. Cool looking motor though. Alright, let's see. Let's see if we can figure this out. I wish this wasn't so dry rotted. I can see a wire there. That's probably them. Right in here. I just wish it wasn't so hard as a rock from age. Okay, I don't know if you can see this, but I'm seeing three ends of wire. There's one here. Wait, I'll point to them. I don't know, you probably can't see them. But there's one here. There's one here. Those are the two wires. Okay, so I did find them, and they're in this piece here, which means that they should have a piece of a lead wire on them, just like they did here. See, this one goes in here, and this one goes in here, too. But that one deteriorated where you could get to it. Here, the only thing I can try to do without hurting the coil, well, the shim's moving, great. I was trying to pry on that shim to pop it up, but it's just pushing the shim. And that strap right there is what's holding it, so we gotta get rid of that strap somehow without hurting the cable. Hey, we broke it, good. Now, let's see if we can pry it up now. There we go. Aha, okay. Now to separate it. Something to smash that. Something to chip away at it. Yeah. Yeah, just don't break the wire. Come on. See, this used to be just insulation, well, like a covering to protect the wire, but it was soft. Oh crap, it broke again. See? That stuff is so hard that when it breaks, it just breaks the wire. Got one of them free. There's one. And we got another one. He's getting down in there. There's that one. Another one broke off even further in there, in that hard junk. And then cut it this way and get that knot off. It used to have a knot, now it's just junk. Dried up, corroded junk. And I don't want to cut the one I just freed up. Where are you? Where are you? You'd be going down, wouldn't you? Hold on. Get that shim out of the way. Yeah, I think that's you right there. Oh, maybe not. Might make it look a bigger thing. No. It's just a light. What the heck did it go to? Before I use this one, I want to cut this off. Yanking on things. Where are you? It's gotta be in this wire and in this wire, just like it was in this wire and in that wire there. I gotta get the rest of this stuff out of here to get to those wires. Without causing issue. See, you got a piece of string, you know, they tie around them and then they cover them with shellac. And the shellac's not so much the problem as this dried up stuff that gets on, that they put on there that was pliable when they put it on and then it dries up. And so as a result, you got to get all of that off to get to the string so you can cut the string. See, there's the string there, but if I wedge in it, I could hurt the coil, so I got to be very careful when I cut that string. I get through most of it, but there's still a little bit holding on there. Make a slice all the way across, and hopefully I can just pry this piece up without pushing on the coil underneath. Just like chipping away enamel or something, you know? Like pottery clay or something, dried clay. It's just so hard in there. Can't get in it. I'm thinking that's it right there. Because this one's coming, looks like it's coming right out of the top of the end of the wire. Maybe with this one I can just break it without scratching here. Nope. Sort of like busting the clods of clay. Between them though. Put alcohol on it and see if it'll soften it up a little. So thick. See a wire coming across the top here. That's a good sign. That's the end of one. It might be this one here that's already out. No, it's going the other way. Chase that wire. It's going that way. I'm coming from down here. So I think that's the one that I'm looking for. I'm just going to follow it across the top. See it? Coming across there? Thinking that's it. That's it. We found it. Yay! Okay, now, this is the inside one, and this is the outside one. Let's check the continuity on this one. I'm going to set this thing aside for a second. We know where that one goes, so we'll just slide it over there, way out of the way. Bring this back. Just get this greasy thing out of the way, too. We'll just set it there so I don't get greasy with my good tools. Okay, this back here. Like this. Here's my yellow one. And let's see if we can get continuity on this side. Excuse me? What was that all about? Try that again. Oh, yes? Okay, that's better. All right, now, here to here. 32 ohms. Okay, 32, give or take a tenth of an ohm. And what did we have on this side? This is the best way to find out if one of these guys is shorted. 29, close enough. Then I don't think they're shorted. Actually, my meter ain't even zeroed out, but that don't matter either. All right, let's get an accurate. Okay, push that back on, that's on. Okay, no, zero that out. No, zero. Try again. Not minus 0.1, zero. Thank you. Okay, now we can get an accurate ohm reading. So this one is 14.6 ohms. And this joker okay, 15.3. So they're about the same. And that one there, I've got to be careful. It's going behind that shim, and that's what's wedging it in there. That shim, yeah, it's tight. So I got to watch that. But the end of that one is this one here. So if I need to dig it out, I can dig it out. But right now I got enough I can solder a lead on. So what we want to do is check this data first off. So I get a couple wires. We got a green. That don't matter, just a couple wires. Okay, so we want to jump this one across. I think it's going to be this one. That's the outside. What's the one that goes all the way across? Looks like it doesn't matter. Oh, it'd be this one, yeah. We want to jump this one, that inside one, to this inside one here. Okay. Then we want to jump these two to some AC and see if that coil is any good. Alright, so I need a suicide plug. Let's see. That's a suicide plug. Is it any good? Yeah, that's a good one. Leveled. Okay. Almost. It has a whole bunch of knots in it. It's an antique rubber cord. Plug that in. Put the other end of that. Put it on here. I'll just strip this side. Put that on there. Put this one on here. Okay. Gently set that there. Turn it on. Give it about 60, 70 volts. I got it up. Wow. And it has a little bit of an issue. I got it on about almost 70 volts, and it's showing 46. Of course, the chunk of it is over my current limiting bulb there. Oh, but we got a magnetic field. See that? And the side too. Okay. But I'm not liking the fact that on 70 volts I'm only showing 47, and my little light up there is showing the rest. That ain't too bad though. Okay. So I'm thinking, I got them two right, that would be the, look at it a little closer. If they're backwards, if I wire them backwards or incorrectly, alright, this one is coming from this side down through here, and this one's going from this side down to there. So I'm thinking this is the inside, and this is definitely the inside on this one, and this is, looks like the outside. Okay, there's our motor. Turn that off. Put that back there. Put this here. Let's get rid of this little plate that's full of gunk. So now, before we even attempt that, we got to deal with this. So I got to clean this off a little. Oh, it's coming out. Oh, well, that's nice if it would come out. Let me get some more alky. I call liquid gold. Not quite as bad as it was, but it's pretty bad. They can't afford it. This armature is in bad shape. I don't know if this motor has any hope at all. I'm going to pull it all the way out because. See if I clean it off of there. Clean it off a little bit here. Grease and gunk and all kinds of stuff on there. That's better. Okay. Now I'll put some more oil on it. Here. And back in here. And push it back in. Yeah, now look at there. Okay, now we can do a fair assessment. So put this back in. There we go. Oh yeah, that's right, I just screwed in to the front. Interesting. Geez, this is all rusted. Okay. Keep the armature in the back. Okay. It's spinning a little bit. Okay, now we need jumper wires again. This one, I'm going to come around the back of the motor here. Connect this one here. And this one, going to come under here. Actually, I'll just come that way and let it drip. That's going there. Okay. And then what's the other one? Oh, okay. That's hot. Okay. Let's connect it up here. And here. Alright. This is about 10 volts, but let's see. Okay. We have the motor, but it's not very good. And it's registering almost a short. Okay, it is possible that I've got the wire wrong. And the only way to find out would be to reverse it. So let's try that. I'm going to drop the voltage down. And I'm going to try to reverse it and see if it makes a difference, if it'll make it worse, if it makes it better. We don't know. Let's see if that is any better. No, that seems worse. I think I had it right. What are we doing on current? 340 milliamps. Alright, at 62 volts, we're drawing 390 milliamps. So let's remember that. 62 volts, 390 milliamps. Let's switch this one. Okay. We're not doing nothing here. But my light ain't lit. Okay, I don't have a connection somewhere. I'm not doing no current at all. So one of these is not making contact. Let's find out which. I'll be this guy. And this one, let's try it again. Okay, we got contact now. Alright, I'm at 62 volts roughly, 340 milliamps, so same thing. Okay, but my light's not on hardly at all. Let's see, 350 milliamps. 70 volts, 400 milliamps, and my light's on pretty bright. 440 milliamps, that's a lot of current for that. Let's see, hold on. Alright, 67 volts, 17 watts. Not really bad, 380 milliamps. But it's not spinning either. Now it was stubborn getting this cleaned up. But we're not getting no power at all. Alright. I'm going to have to do some research on this and try to figure out what kind of motor this is and how these are supposed to be connected. The other one's shorted, so there's no sense in me even trying to deal with it right now. I need to get one going that I know is good, and that's this one, and then try to figure out how, if the other one can be repaired after. But I can't repair the coil, I can't work on two things at once, you know. When you're dealing with science, you work on one thing at a time, change one variable at a time. Right now, this is turning, but not doing enough. So, where am I going? I'm going from outside to outside and inside to inside, and that ain't working. I think I've tried just every arrangement I can try, right? I went, let's see, let's take these off. I went from here to here, and I went from here to here. And I switched those two earlier, which would have been from here, in here, out here, in here, out here, and that didn't do it either. There's no sense going the other way. I don't know if it's AC, it wouldn't matter. It's AC. So it wouldn't matter. Unless this is a DC motor, and if this is a DC motor, I'll never know. I need to know what this motor is, other than really cool looking. These covers don't give me any clue at all. I think, get that screw out of there. I think the customer told me what the motor was when he signed up. Let's see if I can find that. Oh, shut that off. Okay. I'll be back. I'm going to have to figure this out. Okay, this one here is definitely short. You can see the wires here. I don't know if my phone will... Hold on. You can see how those are scraped beyond belief there. That one is... The copper is actually flattened on those, see it? Like they were smashed. They're shiny they are and smashed, they're shorted. On this side is the worst. And that's the one I showed earlier where the wires busted. And a whole bunch of the wires are busted and smashed. See now? So that one needs to be rewound. It's beyond what I can do. I can't do anything with that fan. This one, I don't know. I got it turning, but it turns like a crawl. It just crawls. I broke it free, it was locked up. Both of this one's locked up too. And it's tight, but it's turning. And I oiled it. I can take it out and clean it more. You see where it goes through back there, it's nice and clean. And up there where the gear goes through, I oiled the heck out of that. And in the front of the stator, the armature, I oiled it. And so it's all oiled. But that's not the problem. These armatures are not that great either. See how they are, the plating is gone right off the armature. That's where the plating is scraped off. These fans are toast. They're really not worth putting money in. It would take me hours to get this to work right, and the labor cost would be pretty high. I do have the 4 wires that were showing when I opened it up, which you've seen in the video, and I'm pretty sure that these two go together, and then these are the inputs. These two go together, and these two are the inputs. So basically, the way it's wound is it's wound. I was going to unwind it. This would be the one that is on the outside, and I would unwind it first till I got all of it unwound, and that would take me to the end, which is here. And then that one would go across here, and that would be the inside of that one, and if I unwound it all the way, it would take me to this one. So these are the outer ends of both coils. And of course, you need to go through both coils. You have a magnetic north and a magnetic south. By the way they're wound. This one is wound one way, and the other one's wound the opposite way, and that creates your north and south poles. Which creates the magnetic field and a little bit of torque for the armature to get going. And then once the armature starts turning, that magnetic field is continually going around, and the armature is following it. Actually, the armature is being pushed by the magnetic field going around because it's an AC 160 hertz signal. So the AC line is a sine wave, and it's coming in, and it's doing that. And as it goes up, the north pole is on one side. As it comes down, the current reverses, the south pole is on that side, and the north and south and north, and they just switch them back and forth. Actually, they're going around the armature, the magnetic lines of field, and that's what pushes the armature in a circular motion and pushes the armature. However, this armature is not that great. And so these lines here that are in the armature, those are what react to the phase shift of the signal of the alternating current. So the magnetic field changing direction pushes on these pieces of the armature, these grooves in the armature, and that's what pushes the motor. But this armature is so short that I'm afraid to give it full current because I might just burn it up, you know. I mean, I can try it, but I'm not going to be at risk to try that. I've got it up to 67 volts, and it was drawing 390 milliamps. But a part of that is my current limiting bulb up there on the top, which you see I have the switch up here, it's on. So it was taking some of the power there, but my watt meter here is what tells me how much is coming out of that plug. And there was 17 watts coming out at 60 something volts. I mean, I hate to throw this up to 120 volts and see what happens, but we can. You can't, I mean, the worst you can do is, you know, fire the armature, which is already in such bad shape it isn't going to matter. But, you know, it's just not really worth fixing them. This one maybe. This one might be fixable. That one would have to be rewound. That would be extremely expensive and has to be sent out to a company that does that. This one, if I solder a copper wire from here, run it along the inside in shrink wrap and connect it there where it belongs, then I got my AC coming in here. I can do that and give it 120 volts. It'll either run or it won't. If it runs, great. If it burns up the armature, I'm not going to be responsible for that because it's in too rough shape for me to risk doing it. So that would be your call. That would be the owner's call. If the owner wants me to risk that, I will do it. If not, then, you know, I'll just reassemble them, put a couple of screws in them, you know, just the screws that were in them. I'll just put them back in and maybe one or two others so they don't fall apart. Just generic screws and ship them back. But at this point, all I can say is this one has potential, but I don't want to be responsible for this stator because, and it's of power and at full power because of the condition. If it was spinning at better at 70 volts, I'd feel better. So anyway, there you have it, and it's the owner's call on this one. And if he decides to pursue it, then I will make a follow-up to this video. If not, I'll take this video down. But you see what we got. Thanks for watching.